Welcome to Algebra 2. Today we've got section 11.4 on experimental design. Now, I know I say this every section it seems like, but really the statistics chapter we've been using a lot of language, right? It's a lot of evaluating and analyzing different surveys and samples and things of that sort. So now we're going to look at how experiments are conducted or studies are conducted and how the data is pulled from those studies regarding our samples. So we've learned how to sample a group. Now it's time to look at how the experiments can actually bring about the results we're looking for. So another lesson with not a lot of math involved, but again, a lot of language going on here. All right, so the types of experiments we could have, we want controlled experiments. So we are looking at two groups studied under identical conditions with the one variable that we're analyzing being allowed to vary. Ordinary conditions, we call that a control group. You've probably heard of this language when you hear about drugs being tested and things like that in the medical field. The other group then is the one that receives the drug or the treatment. We call that the treatment group. So we want to be sure, again, we've got random samples. We want to randomly assign subjects. We don't want them to know if they're in the control group or the treatment group. So they are randomly assigned to those. And then this big concept here, we're looking for a randomized comparative experiment. That's why we only have one variable. We can compare those who got a placebo to those who got this experimental drug. We're able to directly compare those two groups. Okay, the placebo, again, you've heard of that. That's just something to cause people to feel like they're being involved in the treatment group when actually they're in the control group. It again causes no external variables to occur other than the one we are experimenting on. Another thing is the sample size in our experiment. Kind of like with probability, we want a huge sample size because that improves the validity. If we just test this on a couple people, well, we don't know if we have something that is truly valid or not. So we need to make sure that we are incorporating large amounts, and then for an experiment to be really valid, it needs to be replicable. We need to be able to repeat the same experiment and get the same results. Okay, a lot of science terminology here. Now, one of the major concepts in statistics is a lot of times when you hear the results of an experiment or a study or a survey, you want to assume that it is a cause and effect, that one thing is causing the other, when actually it's merely a correlation, two things that correlate to one another. So when we do an experiment, then we actually have the control there, right? We have our two groups, we have the one variable isolated. Then it is possible in that experiment to have a cause. So it's possible to have causality or causation, I'll probably refer to it as. In an observational study, this is more like a psychological, you tend to see these more in psychology, where the data is actually collected just by observation. So by observation, we can only come up with correlation, but it is possible in an experiment to get causality there. Okay, and that's what this second little blurb here is saying. More vocabulary. Okay, so we're going to be looking at some different experiments and just trying to pick those apart. So our first example, determine whether the study is a randomized comparative experiment. If it is, describe the treatment group, and the control group. If not, explain why not, and whether the conclusions from the study are valid. So again, we want that comparative experiment to happen. That's what would show us that causality that we're looking for. Here we have a study that says milk fights cavities. At a middle school, students can choose to drink milk or other beverages at lunch. 75 students who chose milk were monitored for 1 year, as were 75 students who chose other beverages. At the end of the year, students in the milk group had 25% fewer cavities than students in the other group. All right, well now, looking at this, it's happening at a middle school, and it's just what's happening at lunch. So we have so many other variables that happen outside that middle school, outside that lunch, that could determine whether or not um, the students are getting cavities or not. This is definitely not a randomized comparative experiment. I'm just going to abbreviate here for sake of space. Randomized comparative experiment. Okay? And if not, explain why not. Well, why not? There's no control versus treatment group. Okay, so they have not specified. They do have groups, right? 75 students were monitored for a year. 75 students that did not drink milk were also monitored. So it seems like we have our two groups, control versus treatment. But in order for that to happen, um, there's so many other variables what happen outside of school that they are not truly controlled groups happening there. Um, so there are other factors. Another claim that I would make, the conclusions would be invalid. Um, Because, yeah, we're comparing what they're doing at lunch, but there could be a whole slew of other possibilities. So other variables are present, just like brushing teeth. So we don't know if the students that we're monitoring in the milk group, maybe they're more likely to brush their teeth more at home or something like that. That's another variable aside from just the milk that is under our observation here. So this experiment does not set up those control versus treatment groups. Um, if it was something where they're monitored 24 hours a day and one group only drinks milk with their meals and the other group only drinks other beverages at all of their meals, and there are things like they're eating the exact same lunch every single time as between both groups, the only thing changing is milk versus not milk, that would be a randomized comparative experiment here. So too many other variables for this one to work. All right, our second example, explain whether the research topic is best investigated through an experiment or an observational study. Then describe the design of the experiment or study. So again, just trying to separate that correlation versus causality thing. I'm so tempted. I'm used to hearing causation, so if I use that word, I'm sorry, but the textbook does use causality. Back to the English language stuff again. Number 8, a restaurant chef wants to know which pasta sauce recipe is preferred by more diners. Okay, is this something that he should just observe or that he should conduct an experiment for in order to get the best results? Well, looking at this, I think immediately to all of the, oh, you see commercials on TV for blind taste tests and things like that. I think he could conduct a very nice experiment here to make this work. So I think an experiment is the best way to do this because, yeah, he could observe what people order more frequently, but that's not really telling him which sauce is the better sauce, right? It could just be a customer's preference. So he could conduct an experiment where maybe there are two similar types of sauces or something, and he has two groups, and he gives one group one recipe, another group another recipe, but he is able to control everything else about that. And so here's how we would set that up. Two groups randomly chosen, and then they're given each type of sauce with all of the other variables constant. That way, this chef is isolating all of the variables that could possibly change people's preference. The only thing changing is the sauce. He'd be able to collect some good data on which sauce is best then. And since they say which sauce recipe, we're imagining like it's not like Alfredo sauce versus marinara sauce, right? It's just two different recipes of the same type of sauce. So he could do a satisfaction survey or something like that when they finish their meal. Find out which is preferred that way. Number 10, you want to know whether homes that are close to parks or schools have higher property values. Well, here we can't really conduct an experiment. It's more that we are looking at all the different property values and kind of trying to find a relationship there. We're trying to observe something that's happening there. So this is one where an observational study is best. And if you think, okay, trying to set up your control group and your treatment group with this, it just wouldn't be possible. You have to just observe the different property values and their proximity to a school or a park. Um, so here we're choosing our groups of homes and comparing their property values. Good word here, proximity. And again, I love this example because these two problems together show the difference between an experiment where we can isolate our two groups. One is the control, one is the treatment, and then something that has to be observational that just shows us correlation. So the experiment, it could possibly give us a cause, but the observation cannot. It could just correlate the location of the home with its property value. I never thought you'd have this much vocabulary in a math class. Example 3. A researcher wants to test the effectiveness of reading novels on raising intelligence quotient scores. Identify a potential problem, if any, with the experimental design, then describe how you can improve it. All right. So we're looking at their experiments here and deciding on whether this is going to give us nice, valid data or whether or not improvements need to be made. So letter A, the researcher selects 500 adults, randomly divides them into two groups. Okay, so they are chosen. It's not one of those surveys that could contain biases or anything like that. Random selection. One group reads novels every day. One group does not read novels, so we have a clearly established treatment and control group. At the end of 1 year, each adult is evaluated and is determined that neither group had an increase in IQ scores. All right, this sounds like a pretty sound experimental process here in letter A. We've got our random sample. We've got the group set up, a control and a treatment group. And then at the end of 1 year, they're evaluated, and it was found that there were no increase in IQ scores for either group. There are no problems with this. Okay, they've isolated the variable that they're analyzing, whether novels have an effect on IQ. And really, they've gone about this experiment in a very, very nice way. That's the variable that they've isolated, and their experiment is working really, really nicely. Letter B says 50 adults volunteer to spend time reading novels every day for 1 year. 50 other adults volunteer to refrain from reading novels for 1 year. Then each adult is evaluated and it's determined that the adults who read novels raised their IQ scores by 3 points more than the other group. Well, I see one big thing right away. They're using the word volunteering. So that is a self-selected group. It's not a random sampling per se. So the people that are volunteering to read the novels for 1 year, maybe they're people that are doing things other than reading novels that would boost their IQ scores. So it's not necessarily random. Okay, so yes, they're comparing the readers to the non-readers. So it is comparative, but it's not random. So the fact that they're volunteering is definitely having an effect on this. I'm just going to put that word there. The self-selected, that's what we called that type of sample. Other factors may be influencing the IQ score. Okay, so maybe the people that are reading novels, maybe they're the ones that are, I don't know, doing other activities and things like that, where the people that are voluntarily not reading, well, maybe they're not doing a whole lot outside to raise their IQ scores either. There are too many variables at play, and the fact that we have that self-selected sample, definitely not as good of an experiment. And again, a nice comparison between a well set up experiment and one that definitely has a lot of holes in it. All right, that does it. There's a pretty short lesson, just evaluating an experiment, looking for, do we have a random comparative sample? Do we have our groups set up nicely, a control and a treatment group, in order to get get a nice valid response, some nice data out of this experiment. If you take a look at your assignment, definitely a shorter assignment. Again, we just want to recognize what makes a good experiment, what is producing nice, valid data that we can trust.